Okay, so we're on AMC12 year 2001, question number 12, and the question reads, how many positive integers not exceeding 2001 are multiple of 3 or 4 but not 5? So first we want to find in the range from 1 all the way to 2001 that are multiple of 3 or 4 first, then we have to subtract that are ones that are multiple of 5. So basically we start from number of multiple of 3. So if we divide 2001 by 3, we get 167. I'm sorry, 667. And if we divide 2001 by 4, oops, not the best 0 in the world, and we get 500. But when we see those two numbers, we overcount, as in like count twice, the numbers that are both divisible by 3 and 4. So for example, we count 12 twice, we count 24 twice. So basically we have to subtract all the numbers that are counted twice, and they should be both multiple of 3 and 4, so they will be multiple of 12. So we have to find out number of numbers that are divisible by 12 in that range. That gives us 166 numbers. So when we do the calculations, we add the first two numbers, and then we subtract this third one. That gives us 1001 numbers. But we still have to subtract numbers that are divisible by 5, but still are multiple of 4 or 3. So you have to get number of numbers that are divisible by 3 and 5, which is basically 15, and then we have to do the same for 20. So let's do it. So 2001 divided by 15 is, hold on for a second, 133. Oh, and here I'm only taking account of the quotient because we don't really care about the remainder, because it doesn't really matter. And if we divide 2001 by 20, then we get 100. But again, we have the same problem. We overcount ones that are both divisible by 15 and 20. In this case, it would be 60. So we have to subtract that. So we have to count number of numbers between those two that are divisible by 60. That gives us 33. So we use the same calculation. 133 plus 100 minus 33. That gives us a nice number, 200. And then basically the 200 is numbers that are divisible by 3 or 4 and or 5. So we have to subtract 200 from 1001, and we get our answer, 801. Oops. Yes. Thank you, and I'll see you on question number 13.